In every great civilization, there exists a monument that transcends its own time, a creation so extraordinary that it continues to inspire all long after its builders have vanished. In Rome, that monument is the Colosseum. Rising from the heart of the eternal city, it stands as a symbol of ambition, innovation, and the sheer will of human ingenuity. For nearly 2 millennia, this immense amphitheater has survived earthquakes, wars, and the relentless passing of time. But its true wonder lies not only in its majestic form, but in the secrets of how it was built, secrets that continue to astonish engineers and historians even today. In the center of Rome stands an amphitheater that has captivated the minds of engineers, architects, and historians for centuries. This colossal structure, known as the Colosseum, is not just a monument, but an engineering marvel whose secrets we are still uncovering today. Built in the 1st century AD, it served as an arena for gladiatorial combat, theatrical performances, and even mock naval battles. But how did the ancient Romans, without modern technology, powerful cranes, or computer calculations, manage to create a structure that has stood for thousands of years? This story reveals the genius of Roman engineers, the materials they used, and the construction methods that remain incredible even today. It explores what makes this structure unique and why it remains nearly impossible to reproduce with the same durability and elegance. Construction of the Colosseum began in 72 AD on the site of a former artificial lake that once belonged to Nero's Golden House. Draining this lake was no small feat, but Roman engineers accomplished it through a network of complex drainage channels. However, the greatest challenge still lay ahead: how to build a massive structure weighing hundreds of thousands of tons on soft, marshy ground. Roman engineers approached this challenge with meticulous planning and practicality. They knew that ordinary foundations would not support such weight, especially on unstable soil. To solve this, they developed a completely new method that became a model for modern construction on difficult terrain. First, they dug a gigantic trench, about 13 meters deep and over 240 meters in diameter. This was not just a pit. It was a monumental basin that required enormous manpower and precision. Once the trench was complete, the next critical phase began: reinforcing the base. Oak piles were driven deep into the ground, forming a dense wooden grid. These piles, embedded in layers of clay, provided additional stability and acted as reinforcement for the future concrete foundation. When a wooden grid was ready, the trench was filled, not with ordinary concrete, but with a special Roman mixture of lime, sand, water, and volcanic ash called pozzolana. It was this volcanic material that gave Roman concrete its legendary strength and resilience. The mixture was poured in layers, each one carefully compacted to eliminate air pockets and achieve maximum density. The result was a monolithic concrete slab, up to 12 meters thick in some areas. This foundation not only distributed the building's immense weight evenly, but also insulated it from ground movements and prevented sinking. It allowed the Romans to construct one of the largest buildings in human history on land that had once been too unstable for heavy structures. Modern engineers analyzing this base have concluded that the Romans didn't just build a foundation. They created a man-made geological layer, stronger than the natural soil beneath it. This foundation was designed to endure not only static loads, but also dynamic vibrations, such as those caused by earthquakes. The foresight and understanding of materials displayed by Roman builders continue to astonish scientists today. The entire operation required an elaborate logistics network, including specialized roads and lifting systems to transport stone, timber, and metal from quarries across the empire. This efficiency made the construction remarkably fast for its scale. One of the main reasons the Colosseum has survived for so long lies in the extraordinary properties of Roman concrete. Opus cementitium. Unlike modern concrete, which weakens with age, Roman concrete became stronger over time. Its unique ingredient, volcanic ash known as pozzolana, was mined near Naples and mixed with lime and water. This combination initiated chemical reactions that formed minerals capable of resisting water, salt, and decay. These properties allowed Roman builders to construct not only amphitheaters, but also aqueducts, ports, and bridges that still stand today. The secret of Roman concrete was not only in its ingredients, but also in how it was prepared. Engineers used a technique called hot mixing. Instead of slaking lime with water before adding it to the mix, they combined quicklime directly with the other ingredients. This caused an intense exothermic reaction, a controlled internal boiling that formed microscopic mineral structures within the concrete. For centuries, these white lime inclusions were considered a sign of poor craftsmanship. But modern research has shown they were the key to the concrete's self-healing ability. When cracks appeared, rainwater seeped in and reacted with the lime particles, forming a calcium-rich solution. As it crystallized, it filled and sealed the cracks, preventing further damage. Roman concrete, therefore, was not a static material, but a living one, capable of repairing itself. This remarkable feature allowed their structures to endure natural wear, moisture, and even earthquakes for centuries, becoming stronger with time. The Romans built with the philosophy that time should not destroy, but perfect. Their approach was rooted in patience and long-term vision. They did not think in decades, but in centuries and millennia, pouring both strength and wisdom into their creations. This is why their monuments, from the Pantheon's massive, unreinforced dome to aqueducts still carrying water, stand as proof that greatness is born from endurance. Unlike modern materials that eventually fail and demand costly maintenance, Roman concrete embraced nature. Even seawater, the enemy of today's cement, enhanced Roman structures by stimulating the growth of new strengthening minerals. The Romans turned decay into durability. The Colosseum's visible beauty is matched by its structural brilliance. Its design of arches and vaults represented the pinnacle of ancient engineering, merging strength, symmetry, and accessibility. The exterior facade consisted of 3 tiers of arches, each supporting the one above it, creating a balanced yet graceful appearance that concealed its massive weight. These arches were not only decorative, but functional. They distributed loads efficiently while allowing the movement of tens of thousands of spectators. On the first tier, the arches serve as entrances through which people could enter and exit in an orderly flow. The system was so efficient that the entire amphitheater, which held more than 50,000 people, could be evacuated in just 15 to 20 minutes. At the heart of each arch was the keystone, a wedge-shaped stone placed at the top. It locked the other stones in position and distributed the weight toward the sides. Without it, the entire structure would collapse. This simple but ingenious idea enabled the Romans to construct arches of monumental size, used not only in the Colosseum, but in bridges and aqueducts across the empire. Beneath the seating area, a network of corridors and staircases formed the unseen skeleton of the structure. These inner arches, made from Roman concrete, bore the tremendous weight of the stands while creating open passageways for movement and storage. They acted as ribs, giving the entire building both strength and flexibility. This architectural method allowed for multi-story construction that was strong yet relatively lightweight, centuries before modern steel frameworks were invented. While much of this internal structure was hidden from view, it was the true heart of the Colosseum's stability. In the end, the Colosseum was far more than a place of entertainment. It was the embodiment of Roman philosophy that beauty and strength must coexist, that time itself can be an ally, and that true craftsmanship lies not in what fades quickly, but in what endures. And perhaps there is a timeless lesson in that. The Romans built structures that grew stronger as the years passed. If humanity applied the same principle to life, building strong foundations, learning patience, and crafting with purpose, then maybe, just like the Colosseum, what we create today could stand for centuries to come. In the grand story of Roman architecture, the arch stood as one of humanity's greatest innovations. It wasn't just a structural feature, it was a revolution in how space could be used. The arch allowed Roman builders to create vast, open halls and monumental arenas that could hold tens of thousands of people. This design reflected not only the empire's engineering prowess, but also its cultural ambition. The arches of the Colosseum became a symbol of Rome's unrelenting quest for greatness, a belief that beauty, strength, and intelligence could be forged together in stone. Modern construction still relies on the principles first mastered by the Romans. Today, engineers use steel and reinforced concrete to span massive distances, materials that the Romans substituted with stone and a primitive form of concrete. Yet the ancients proved that true strength lies not only in materials but in design. With perfect geometry and a deep understanding of physics, they achieved extraordinary durability using simple elements. The Romans were masters of architectural minimalism, achieving maximum strength with minimal material. Whether out of necessity or intuition, their approach defined an era. To them, the arch and vault weren't just technological tools, they were a philosophy, a testament to the idea that intelligence could conquer weight itself. The Colosseum still stands today as a silent teacher of that lesson. Strength isn't found in mass, but in structure. A well-balanced design, like a well-balanced mind, endures. Inside, the Colosseum was just as sophisticated as its grand exterior. Designed to hold between 50,000 and 80,000 spectators, it featured a highly organized system for safe and efficient movement. The Romans called this network the vomitoria, from the Latin vomere, meaning to spew forth. It described the entrances and exits that allowed massive crowds to enter or leave the arena within minutes. There were 80 arched entrances on the lower tier, each numbered to guide people to their seats, much like modern stadiums with sector and gate numbers. Corridors and staircases connected different seating levels, carefully separating social classes while ensuring smooth circulation. Every tier in the Colosseum reflected Rome's strict social hierarchy. The emperor, senators, and vestal virgins sat closest to the arena in the most prestigious section, the podium. Above them were the equites, the wealthy knights of Rome. The common citizens, or plebeians, filled the higher levels, while at the very top, in the wooden sumacavia, sat women, slaves, and the lower classes. This design wasn't only symbolic, it was practical. It maintained order among tens of thousands of spectators. The stairways and corridors were designed to prevent opposing traffic, channeling the crowd in one direction toward their seats. The narrow passages of the vomitoria opened dramatically into the bright expanse of the arena, creating a sense of freedom and excitement. Even in emergencies, the Romans thought ahead. Modern engineers estimate that the entire Colosseum could be evacuated in just 10 to 15 minutes, an astonishing achievement for its time. Beneath the arena, an intricate world thrived. A maze of underground corridors housed gladiators, wild animals, and stage machinery. Lifts and pulleys, powered by manpower, could raise cages, scenery, or even entire platforms into the arena, creating stunning and unpredictable spectacles. This hidden infrastructure revealed just how advanced Roman engineering had become, blending art, logic, and theatricality in perfect harmony. The materials that made the Colosseum so enduring were just as ingenious as its design. The main stone was travertine, a light-colored limestone quarried from Tivoli, about 30 kilometers from Rome. Strong, weather-resistant, and easy to carve, it was ideal for the massive load-bearing outer walls. The blocks were fitted together without mortar, held in place by iron clamps covered in lead, a design that gave the structure both strength and flexibility against earthquakes. The travertine facade became the Colosseum's signature, gleaming in the Roman sun as a testament to durability and beauty. For the inner walls and arches, the builders used tuff, a lighter, more porous volcanic rock that reduced the overall weight of the building. Bricks and Roman concrete, known as opus cementitium, completed the structure. This concrete, made from lime, volcanic ash, and crushed stone, was one of Rome's most brilliant inventions. Its unique composition allowed it to harden even underwater, making it perfect for foundations and vaults. Pumice from Mount Vesuvius gave it an extraordinary resistance to time, one of the secrets behind the Colosseum's survival for nearly 2 millennia. Inside, the amphitheater was once adorned with marble and bronze. Imported marble slabs decorated the noble seats and walls, while statues of gods and heroes filled the niches between arches. Bronze railings and ornaments added to the splendor. Over the centuries, much of this decoration was looted. Even the metal clamps holding the travertine were stripped away, weakening parts of the structure. Some of these stolen materials later found their way into other great works, including St. Peter's Basilica. Constructing such a monument was a logistical feat of incredible scale. Thousands of laborers, slaves, soldiers, masons, and engineers worked together with precision and coordination. Stones were hauled from quarries along special roads built for the project. Cranes, pulleys, and winches lifted massive blocks into place. Each phase was carefully organized. First the foundation, then the walls, followed by the interior tiers and finishing details. Remarkably, the entire project was completed in just 8 years, a speed that still amazes modern engineers. The Colosseum was more than an entertainment arena. It was a machine of civilization, an embodiment of Rome's values: power, order, and endurance. Every brick, every arch, every carefully calculated angle reflected the belief that through discipline and intellect, anything could be achieved. And yet, amid all its grandeur, one question remains. How did they manage to build such magnificence under the scorching Roman sun, without modern tools, or even bottled water for the workers? That's the mystery we'll explore next. In ancient Rome, the construction of the Colosseum stood as a testament not only to manpower, but to the unmatched brilliance of Roman engineering. The project wasn't just about stacking stones. It was a carefully orchestrated masterpiece of logistics, supply, and organization. One of the key challenges was the water supply. Fortunately, Rome already possessed an advanced network of aqueducts that brought clean water into the city. Engineers extended this system directly to the construction site through temporary pipes and reservoirs, ensuring a constant water flow for workers in the scorching climate. That same water mixed the mortar and hydraulic compounds that held the massive structure together. The work never stopped. Thousands of laborers toiled day and night in shifts, each assigned to a specific zone of the project. Some dug the foundations, others laid bricks and concrete, while teams of artisans installed marble cladding. The workforce was a structured hierarchy, from skilled masons and carpenters to unskilled laborers hauling materials. This division of labor minimized downtime and kept the operation running with astonishing efficiency. The scale was immense. Historians estimate that roughly 100,000 cubic meters of limestone and 300,000 cubic meters of travertine were needed, travertine being a strong limestone quarried in Tivoli, about 20 kilometers away. To move it all, the Romans built a special road to the Anjine River, where ox-drawn carts delivered the stones to barges that floated them down the Tiber Strait to the building site. Water transport was far faster and more efficient than hauling overland. The Colosseum's internal vaults and arches were made from Roman concrete, known as opus cementitium, a revolutionary material that was both strong and light. Its secret ingredient was volcanic ash, which, when mixed with lime and water, created a chemical reaction that produced a self-reinforcing material even stronger than many modern concretes. This innovation allowed Roman engineers to build soaring arches and stable vaults that defined the amphitheater's elegant form. Every part of the construction process reflected Roman precision. Scaffolding, cranes, pulleys, and winches powered by people and animals lifted enormous stone blocks to great heights. Lead brackets secured the blocks together, sometimes filled with molten lead for extra stability. These details ensured the structure's endurance for millennia. The Colosseum's water system was just as impressive as its architecture. Beneath the arena lay a complex network of channels designed to drain rainwater and, according to some sources, to flood the arena for staged naval battles known as naumachii. Aqueducts like the Aqua Claudia supplied this system, feeding fountains, latrines, and cleaning facilities for tens of thousands of spectators. The same network linked to Rome's Great Sewer, the Cloaca Maxima, efficiently draining waste and water. This integration of supply and drainage demonstrated an advanced understanding of hydraulics and public health rarely matched, even centuries later. The Romans even managed to regulate the water level in the arena, an engineering feat that required precise control of flow and pressure. Whether naval reenactments were regularly held or only during the Colosseum's early years, the capability itself highlighted an extraordinary mastery of hydraulic engineering. Water in Rome symbolized civilization and imperial power. By equipping the amphitheater with abundant water, emperors not only served the public, but displayed the empire's technological might. Inside, fountains and cool air created a comfortable atmosphere that reminded every visitor of Rome's grandeur. Another marvel was the velarium, the massive retractable awning that shaded the audience. This enormous canopy was operated by sailors from the Roman Navy, experts in ropes and rigging. Masts fixed to the outer wall supported thousands of meters of hemp ropes and linen canvas. Sections of the awning could be adjusted depending on the sun's position, and the whole system required coordinated effort from dozens of men. Even today, historians debate exactly how the mechanism worked, though traces of its anchors can still be seen on the Colosseum's upper walls. The velarium did more than provide shade. It improved airflow, creating a natural cooling effect inside the amphitheater. This ingenious design kept spectators comfortable even during long, hot Roman days. It was an early example of climate control, merging functionality with spectacle. The sight of sailors manipulating the giant canopy must have been a show in itself, symbolizing the empire's technical dominance and attention to comfort. The materials used were carefully chosen: linen for its lightness and density, spruce wood for masts, and hemp ropes for strength. The system mirrored a giant ship's rigging, only on an architectural scale, a perfect blend of naval technology and civil engineering. Building something similar today would not be easy. The secret of Roman concrete, a self-healing mixture of volcanic ash and lime, has only recently begun to be rediscovered. Modern materials, though strong, lack its regenerative properties and longevity. The cost and logistics of quarrying and transporting natural stone like travertine would be astronomical by modern standards. And while the Romans relied on armies of slaves and prisoners to build the Colosseum in under a decade, modern labor laws and safety standards would extend such a project for decades, even with advanced machinery. Despite earthquakes, fires, and centuries of looting, the Colosseum still stands. Stones from its walls helped build landmarks like St. Peter's Basilica, yet its surviving arches and skeleton remain one of the most recognizable symbols of Rome. Its structural brilliance lies in the careful distribution of weight through a network of arches and vaults, a design so stable that it has endured for nearly 2,000 years. Today, the Colosseum is not just an ancient ruin, but a living reminder of human ingenuity. It continues to inspire engineers and architects around the world. Its use of local materials, sustainable methods, and efficient design offer valuable lessons for the modern age, showing that durability and beauty can coexist without harming the environment. The Colosseum remains proof that greatness isn't born solely from technology, but from vision, discipline, and an understanding of nature's principles. From its volcanic concrete to its grand awnings, every detail tells the story of a civilization that mastered both art and science. And even now, its shadow across the Roman skyline reminds us that true engineering genius never truly fades. So, what other ancient wonder do you think deserves a deep dive like this? Leave your suggestions in the comments, and don't forget to subscribe so you don't miss the next story.